Alright, question 25 says, factor the expression, use fundamental identities to simplify if necessary, and there is more than one correct way to write the answer. Okay, so the first preference I would have is to put the biggest exponent first, then the next biggest, then the next biggest, in standard position like that. And so they're telling us to factor it. So this is similar to x to the fourth minus 2x squared plus 1. So if I'm trying to, well, you can do the product sum thing that we talked about. Again, I don't like to do that all the time because it's a little more time consuming, but if the factoring is what's giving you trouble, then you've got to have some other backup. So, but I always am going to try guess and check first. So just like over here, I suspect this is probably going to be x squared times x squared to give me x to the fourth. It's probably going to be cosine squared times cosine squared to give me cosine to the fourth. Over here, minus 1 times minus 1 multiplies to plus 1. And if I FOIL, I'd have minus 1x squared, minus 1x squared, which combines to be minus 2x squared. So this guy is going to have the same format, like so. So there's the factor part of the question. And then it says use fundamental identities to simplify. So I've got the same thing twice here. And this guy looks similar to the first Pythagorean identity. So I would probably write the first Pythagorean identity down and then see if I could solve it for this. So I could subtract over the sine squared, and then I could subtract over the 1. So it looks like instead of saying cosine squared minus 1, that's the same thing as negative sine squared. So that's what they mean in the directions by use fundamental identities to simplify. Well, this is the exact same thing, so I just get to reuse that. And now I'm about ready for my answer. Negative times a negative is positive. Sine squared times sine squared would be sine to the fourth. Okay, anything more specific? 25?